We're going to now focus a little closer to home with one of our own, Dr. Antonio Mallarino, that's in the Department of Agronomy here at Iowa State University. Dr. Mallarino has been working for a number of years to document the performance of infield practices and ways at reducing dissolved and particulate P losses to the environment. So we thought that would be a great way, after we've talked a little bit about the impacts of P on water bodies and processing of P, a little bit about what we can do to reduce P loss to downstream water bodies. I would encourage you to go look at the Iowa Nutrient Research Center seminar recordings. They're all on our website. We've adjusted things a little bit on the website to make it easier to find the videos. So hopefully you can go back and find those. And with that, I will turn it over to Dr. Mallarino. When he gets done, we should have, as long as he doesn't take all of the time, Dr. Mallarino, we will have some time for questions of him, and you'll be able to either type those in the chat box or unmute yourself and ask him. So I'll turn it over to Dr. Mallarino, and as he starts, if somebody could just type in the chat box if they could hear him okay, it would be much appreciated. Thanks. And over to you, Antonio.
Okay, thank you, Matt. It's a pleasure to be in this cool afternoon, being at the office to give this talk. I will try to just do a quick summary of work that my group has done, over the years, and much of the recent research has been funded by the Iowa Nutrient Center. So, but I will explain that in each situation. So the idea is to give an overview of the work that we've done, mainly at about what's happening with dissolved P, because we know, given all these impacts, in the Great Lakes, that it's been given a lot of importance to that. So when I start any phosphorus and water quality talk, I start with this, because most likely there are some consultants listening. And I want just to send the message that the first step in order to avoid contamination of water supplies with phosphorus is to do good crop management, crop and soils management. So we need to know the optimal soil test levels, use cost-effective rates for deficient soils, and use removal estimates to maintain soil test values over time. We should recognize within field variation in soil test P, yield, and removal. As you know, I have been working a lot with soil sampling and testing and variable rate technology. I think this is something that is available. Most people should be using today. And then, especially in Iowa, of course, we want to use the nitrogen in manure, but this has to be used carefully because, especially with poultry manure, with N-based application, the soil test P builds up very fast. And of course, with any manure in continuous column. So, okay, we can define the phosphorus fractions in runoff. I will emphasize runoff. We did some study with Helmers with tile drainage too. But the easiest to understand in terms of what people measure out there is dissolved P, which has the largest impact on algae growth and water impairment. But depending on the hydrology of the receiving water, it may have, a short-term effect. Of course, with tile drainage or subsurface drainage, most of the phosphorus is dissolved P. In sulfur runoff, there is a very wide variation in the proportion of dissolved P. This is a orthophosphate measured in a couple of different ways that I will talk later on. Then we have the particulate P, which is the phosphorus bound to soil particles, which have a slow but long-term impact on water quality The impact is very variable depending on conditions, but in Iowa lakes mainly, or other lakes that are shallow, this is a very important source of bad water quality because of the effect of wind, fish, boats or things like that. So both are considered by the Iowa P index. Now, in the nutrient reduction strategy, until now, we have been emphasizing the total P reduction, okay? Now, from the beginning, it was said that this issue of the dissolved P in the future would have to be considered, except at the time we didn't have much data. Now, I borrowed this from somebody, which I don't remember. Of course, when people talk about phosphorus impact on water quality, the first thing they think is high soil test or erosion or things like that. But it is very complex. There are all kinds of factors that affect the transport. You see, we may have high soil test P in some soils, but if there is no much runoff or tile drainage, and that phosphorus doesn't move too much, then it's not a big deal. But so we need to consider all these issues that are considered in one way or another in the P index or other tools. Now, I have this slide here because I will be referring a couple of these things, and my intention is not to define things because a couple of the concepts there, still there is not much agreement between people working in phosphorus water quality, but I think it's useful to remind people what we are talking about. When we are talking about surface runoff, most of the time, we have the dissolved reacted P, okay, which is measured after filtering through a very fine filter, okay, and if it is measured colorimetric with the method of Murphy and Riley. Okay, so that's the most common dissolved P measurement. Then we have total dissolved P, which is additional phosphorus, and the measurement is also after filtering through a very fine filter. But the old method was with digestion. See, after filtering, do a strong acid or alkaline digestion, and then measure with either colorimetric method or with ICP. But since the ICP became more common, and lots of research have shown that with ICP, we measure more phosphorus in extracts from soils or runoff than measured with the colorimetric Murphy and Riley method. Then some people are using just the direct ICP measurement after the filtering through the fine filter without digestion. And we did several comparisons here with both methods, both for surface runoff and tile drainage, and we get exactly the same thing. So I'm not going to show that. Then we have a bioavailable P that I'm not going to show too much about this, but this is essentially the classic Sharpley method with a filter paper impregnated with iron oxide, which measures the dissolved P, orthophosphate P, but because there is an agitation for many hours, I think it's 17 hours, then measures also other forms of dissolved P that are released during that long time of agitation. And then we have total P, which there is a strong digestion, and the measurement, once it is digested, measuring with the colorimetric method, ICP, is the same thing. There's no difference. Now, people working on some surface drainage, tile drainage and other things, often measure something that is called total reacted P. And I put here a question mark in the filter because most people filter and then use the colorimetric Murphy and Riley method, but others, because in surface drainage often there is not much sediment at all, they don't filter. So now as I said, there is different people use different ways, this total reactive P. But in this presentation, I'm going to talk about subsurface drainage. Okay, we have known for a long time that there is a relationship between soil test P and the dissolved P loss with surface runoff. This is some data that we got here in Iowa years ago, and shows that this is across many till and tillage. And the graph on the right measures the correlation between the soil reactive P and the soil test P to a 2-inch depth, okay? Note this, and then so there is a good correlation, it's linear. We seldom find a curvilinear or exponential relationship in Iowa, even at those high soil test P levels. And then here on the right, we have the 6-inch sampling depth, exactly the same study, the same site. So we see that when we sample, as you can expect, by sampling the top 2 inches, there is a better correlation because that's where much of the P is extracted in surface runoff. But there is also a correlation with the 6-inch depth, and because most people use a 6-inch sampling depth for crops, that's also the one used in the P index. And by the way, I'm showing here just Bray. In others, I will be showing Melick 3, but we did all kind of different methods, Olsen, Bray, Melick, and also soil water extractable P, and also soil P saturation, but the relationships are about of the same type. Now, we also have known for a long time that increasing the rate applied increases the phosphorus loss. In this case, I'm sorry, you will see sometimes I use English units, sometimes I use metric units. So this is a very recent study that we did with my PhD student, John Jones, and we put together lots of field trials, and these are the averages across sites and years. And we have 3 rates, 0, 50, and 100 pounds P2O5. By the way, the 50 is about the annual maintenance, the 100 is about the 2-year maintenance for the consoil rotation, approximately. So, so we cannot actually fit these curves, because we have only 3 points, but there is a perfect fit. And note the different units for total P. So it is clear that when we apply the 100 pounds compared with the 50 pounds, we get much higher losses, and much of that is dissolved P. This is concentration. Okay, another thing that happened is that, which you can see here, what is better shown in this graph is that when we have high soil test P levels, usually much of the P loss is dissolved P, okay? So here we have the ratio total P and DRP versus soil water extractable P. And this is the Melick, which in Iowa was about the same things as the Bray, the same ratio. So you can see that with say a soil test of about 50 ppms or higher, essentially the majority of the phosphorus loss is dissolved P. This is important, okay? So increasing the rate, increasing the loss, but also the proportion of the dissolved P with runoff. Now, there are all kinds of conservation practices that affect the phosphorus loss, the amount of total P loss, and also the proportion of dissolved P versus the total. And I'm not going to refer to many of these, but these are several things that we know that are useful in terms of reducing phosphorus loss, okay? So the first thing I'd like to show, we have a study a few years ago with Matt Helmers and several others in Northwest Iowa that we were comparing the phosphorus loss from large plots. You can see there's in the picture. So we have conservative rotation 6 years, each crop each year. So we have corn and soybean switching over time in order to get more data. And then with the treatments were no-till or tillage, okay? Fall, chisel plow, or corn stalk, or spring disc. And the P was applied soil test P maintenance of optimum to slightly high soil test P. And we use what many farmers use in Iowa and the North Central region. We apply the rate for the corn soybean rotation only before corn, okay, in the fall. Now it's important that, of course, nitrogen was non-limiting. And then, so we have either P fertilizer, broadcast, or the liquid soil manure was injected. It was a difference, both with the no-till or with tillage. The liquid soil manure was injected, as most people do in Iowa. So these are some of the results that we have. Annualized soil losses for the 6 years. And here we show the soil loss for the corn year, which means the soybean residue, okay? This is the soybean year, which means corn stalk residue. And this is the average for the rotation. Remember that we have both crops each year. So we can see what others have found, but that no-till, of course, reduces soil loss. But the interesting things, and there is data, but not as much, is that we see that in the main problem of in soil loss is in the corn year when we plant in soybean residue, okay? The soil loss in the soybean year are much less, okay? And of course, for the rotation is more or less the average. So in this study, these are the results for the runoff P loss. On the left, we have the fertilizer. Remember that this is the double rate applied only before corn, okay, broadcast. And on the right, the bluish graphs is the same rate, but injected soil manure. So the results for both the fertilizer and the manure are about the same, okay? So I'm going to just to describe for the fertilizer. We see that in the corn year and soybean residue, see, the no-till reduces, reduces the total P loss, which is the gray bar, but increases the loss of dissolved P. Okay, you can see the percentage here is about 20% with tillage, but 54% with no-till, okay? So we reduce the total P loss, okay? But increase not only the proportion, but the actual loss of dissolved P. In the soybean year, it's the same trend, but much less the losses. Now remember that it's not just a residue impact, it's also that we put the fertilizer here before corn on soybean residue in the fall, as most farmers do, okay? So I like soybean, I think it's great, but we have this issue with soybean residue, especially with slopes, okay? So in low testing soils, then when P rates needed are high, apply the 2-year rate for the rotation, you see, but no more than that. Now, most people that have low testing soils apply much more than the rate to maximize yields for 2 years. And then this issue about application in the fall before snowfall or soils freeze is important, not in the spring when rainfall intensity and runoff potential are very high. Okay, and then of course subsurface banding or injected P should help. This is the information we have until about 4 years ago. Now we did lots of study with rainfall simulation with this contraption. This is the rainfall simulator that was developed by the National P-Runoff Project many years ago that I was part of. So we were in many Iowa fields doing these rainfall simulations. So one interesting project of many is that we found that we have 21 fields, we have this comparison, okay? There's 100 pounds of P2O5 applied to soybean residue, okay? And then we did the same rate with beef cattle manure, poultry manure, liquid soy manure, fertilizer. The poultry and the beef manure is solid, of course. Okay, so we apply, now this is the maximum potential loss because we applied and we did the rainfall simulation within 48 hours of the application, okay, 24 to 48 hours. So we can see that, and this has been consistent in many studies that we did in Iowa, not in this one, that the highest losses, okay, the gray is the total P, the black is the dissolved P, which is DRP in this case, are with fertilizer, then with liquid soil manure, and much less with the solid manures. Now we can talk about a lot about this. Of course, there is variation between fields, but this is very consistent. And often this happens that with the beef and the poultry manure is very small, and sometimes it's not even significant, the loss that when no P was applied. Some people are saying that this is related to the dissolved P in the manure, but we have not found that. That works with one source. If you have different dissolved P in the manure for one source, yes, there is a good correlation, but we go across sources and across fields. There is no good correlation between dissolved P in the manure and the dissolved P loss. So we don't recommend, using that test because it's not reliable, okay? The other thing that we investigated a lot, mainly with rainfall simulations in the field until recently, is the timing of the runoff event after an application, and of course the tillage, okay? So this is very important because Iowa soils do not fix, quote, much phosphorus, low P fixation capacity, but they are able to retain phosphorus, okay, which is not the same thing. This is an example in which we, again, using rainfall simulations, we didn't have the beef manure in this case. We compared poultry manure, solid, liquid soil manure, and fertilizer. And we have this, the same rate, okay? And then we had 3 time of runoff events. So within 24 hours event, that is the application, okay, not incorporated. The same 24-hour event, but incorporated, like disking. And then 10 days later, a delay event, not incorporated, okay? We did not have the 10-day delayed event with tillage, okay? So when we look at the difference between the P sources, it's the same that I showed before, okay? But look at this, the difference between, this is a rainfall immediately after the application, okay? This is when it is incorporated. Of course, we reduce the loss by incorporation, but not this. And this has been very consistent in at least 4, 5, 6 different projects that we look at this. That it's enough that that P, no matter the source, is sitting there on the surface, okay, without incorporation, but there is a delay of about 10 days or 2 weeks in the runoff event. Essentially, we are having even less phosphorus loss than when we do the incorporation. This is something that's important, and this worries me a lot for some recommendations in Ohio, Northern Ohio, and the Great Lakes, that they are suggesting people to till if they do not inject or the phosphorus. But of course, the environment there is another plant. Okay, we cannot, for a variety of reasons, we cannot translate the situation to the Iowa conditions. Oh, another way I forgot to mention before, the blue numbers here are the proportion of the total runoff that is dissolved P. Okay, and there tends to be a big higher proportion with fertilizer and solid manure and liquid manure compared with the no fertilization or poultry manure. Just checking the timer. This is another study, but in this case, we have several rates, okay? And this was liquid soil manure. This is a rate in P205 per acre. These were 2 sites, and in the top, we show the dissolved reacted P loss, and in the bottom, in the gray areas, we show the total P loss, okay? And the treatment that we have, this was at the field, of course, we have not incorporated or incorporated for a 24-hour event, a delayed 15-day event, again, not incorporated and incorporated the manure, and then a 6-month event, you know. And we covered the plots, so when there was some rain during these 6 months, it didn't affect the plots. We just allowed, you know, some rainfall that was unlikely to produce runoff to moisture the field. So we see exactly the same thing that we saw before. I mean, you see, this is the phosphorus loss of dissolved P, okay, in the top, when the manure was not incorporated, okay, and this was when it was incorporated. And the blue numbers is the proportion of the total runoff P that was dissolved P. Look, there is a major difference with incorporation. We reduce drastically the proportion of dissolved P in the runoff. With a delay, we cut down really to very, very low losses. And look, even with 100 pounds, which is about the double rate for the corn soybean rotation applied before corn, we see very, very little loss and almost no difference for this high rate. And then 6 months later, which essentially was after the winter, then we see absolutely no difference between incorporation and non-incorporation. And then we can see what happened in total P. You see, with the total P, the difference to incorporations are less, but in the 6 month event or in the 15 event delay, there's no difference between the incorporation or the non-incorporation. So this is very, very important, okay? We are gonna use liquid manure or fertilizer. Better watch the forecast for the next couple of weeks, because if it doesn't rain, then it's not a big deal. But if we get a runoff event, then immediately after application, there the phosphorus will go. Okay, another study is that you may have heard about this study. It was done by Helmers and all kind of people in the Neil Smith Wildlife Refuge. They were looking at corn soybean rotations with no-till and different prairie strips strategies. These were the treatments, okay? I'm not gonna give details. I participated in this project only in 2 years, actually 3, but in one of the years there was not much runoff. And this study show, of course, that the soil loss is reduced by any of these prairie strips. But I collaborated here by analyzing dissolved P. You see, in the previous years, they have not analyzed dissolved P in runoff. They just look at the total P. So here we have the comparison of soil loss, okay, in 2 years. You can see it doesn't matter what type of prairie strips were used, drastically reduce the soil loss. This is the total P loss. And we see that also any of the strips strategies cut the soil loss, and there are small differences, you know, between the strips. In 1 year, the 20% foot slope and upslope combination didn't work as well as the others too for some reason, but there were no statistically significant difference between the strips in terms of total P. Now, when we measure the soil reactive P, look at this. There was essentially no difference in 2013 to any treatment, okay? And in 2014, there was no difference between the treatments either. So the strips really reduce soil loss. It can reduce total P loss, especially the particulate P loss. But in these 2 years that we have the study, there wasn't much dissolved P coming off from these fields. Okay, the other issue that we have a long project with funded by the Nutrient Center is the impact of cover crops, okay? This is important because cover crops, there are lots of experiments that can cut, you know, nitrate losses about 50 or 60% sometimes. And there was only, when we started this study, there was only another study in Kansas, which of course is another planet, completely different soils and climate. And that study was showing that the cover crops actually increase the P loss with runoff. So many people were up to arms in Kansas with the leader of the group. There were many people involved, was Nathan Nelson, Dr. Nathan Nelson, but those are the numbers that he got. So I started releasing numbers for this project only a couple of years ago, because I wanted to be sure that I have, you know, several years, not just 1 or 2 year information. So this was a study, was one site about 5, 6, 7 miles south of Ames, with watersheds that were between 1.5 and 3 acres in size. This is the equipment that we use. Essentially, there was lots of people involved here. I was the PI. The guys that were mainly at the field were Master Hack, Louis Thompson, and Carl Pedersen from Agronomy and Ag Engineers. And in the last 2 years, my student, Gomez Botero, and in the first 2, 3 years, Pablo Barbieri was a postdoc. Okay, we have 6 years, conservative rotation. We started with salted P very high, and we maintained that. Then we have a winter cereal rye crop overseeded before harvest each crop each year. And these were the 4 management systems that we compared with 3 replications. No till, no tillage with cereal rye cover crop, tillage with the classic, okay, not the classic. In this case, we did the tillage in the spring because we didn't want to till, of course, in the fall, the cover crop that has been overseeded. So for both with or without the cover crop, we did the tillage in the spring, about a week after the termination of the rye, okay? Okay, these are the average of 4 years because we did not have runoff in 2017 or in 2020. It was dry year. So this is the flow, okay, the blue graph for the treatments. And we can see that the only, I don't have the little letters for statistics, but the major difference is that with no till, we have the largest runoff flow, okay? With no till, there was no difference, but with the cover crop, really reduced a lot the flow, okay? This is the soil loss, okay? And we show, of course, the no-till reduced soil loss a lot with or without the cover crop. And with tillage, the effect the cover crop is much higher than for no-till. So in both cases, for runoff flow and for soil loss, the impact, the positive impact of cover crop are reducing losses is more with tillage than with no tillage. Again, we can talk a lot about this. We did not have the 2 crops each year here. So we have a confounding effect of the year with the residue. And, but this is what we found on average. Now, this is the result for phosphorus. Again, analyzed. This is runoff P loss. And we have here total P in the gray bars. The black is the dissolved reactive P, and the blue numbers is the percent of dissolved reactive P of the total P. So in terms of the big difference, again, we see that tillage has the highest, okay, total P losses, higher than with no-till. And then the impact of the cover crop, okay, reduces the total P loss, the gray bars with no-till, but the major impact on reducing losses is with tillage. Okay, look at this difference here. Okay. Now, in terms of the actual dissolved P losses, we see that the cover crop reduced the losses, okay, a little bit. And here with tillage also reduce a little bit the loss. However, the no-till, as we saw before, increase a little bit the proportion of the dissolved P in runoff, okay? 51%, 58, 36%, 54%, okay? But the net effect is that the total P loss is reduced and the dissolved P loss also is reduced, although the proportion is a bit higher. So this is in striking contrast with the results of my friend in Kansas, okay? We show here that cover crops helped, especially with tillage, reduce total undissolved P loss, not as much with no-till. Okay, we work a lot with the fertilizer placement, and I can't go into details because I'm getting very close to the end. This was a study that we did for 6 years, okay? And the treatments that we compared was no-till or tillage. And we were trying to maintain soil test P with between the optimum and the high, okay? So there were no great differences, but we have this combination of timing and rate. So we have fall broadcast, the 2-year rate before corn, and planter band, okay, with fertilizer. This is dry fertilizer to each crop. So we are confounding here rate with timing, okay? But this is something that is very practical. You see, most farmers apply this rate, the 2-year rate broadcast before corn, and those that use planter band, they do it each year to each crop. Now, over 2 years, the rates were the same, okay? So this is what we found. And the results were not what we expected. Okay, these are averages of the across 6 years. We wrote a report, an extension publication in 2019, and total P, we see that the only difference is this gray bar, which is the chisel broadcast. Okay, remember, broadcast in the fall had the highest loss. Here we have the particulate P, the same thing. And then the dissolved reacted P loss, the only difference was between the chisel band, okay, when the banding was done each year with tillage, and there was no difference between the other 3 treatments. We are having a tough time trying to explain this, okay, which probably is due to the runoff volume in different years, due to the fact that we were confounding timing with application placement, you see. So this did not help much at what many people believe, that subsurface banding should be great with no-till, because we actually found that the most reduction of dissolved P was with tillage, banding with tillage. So because of that, the Nutrient Center, and by the way, this project was funded by the Iowa Soil and Water Conservation Commission program and the Leopold Center, depending on the year. And then we have a new study in 2019 and 2020. We have 2 years, unfortunately, was funded by the Nutrient Center, but they did not give us funding to repeat it. And here we have, we were comparing apple with oranges. It's all no-till, no tillage, but we have broadcast fall P and broadcast spring P, okay, annual maintenance, okay? Then we have the planted band P, okay, annual maintenance. So we can directly compare this because the rate was the same and the timing. Then we have the broadcasting twice P maintenance only before corn, the broadcast twice P maintenance only before soybean. I really wanted to do this because given what's happening with P losses and soil losses on soybean residue. And then we have a rye cover crop. It's the broadcast twice P maintenance only before rye cover crop. And honestly, I finished working on this graph about 1 hour ago. So we have here the first year. So remember that here is we have timing. So the comparison of the result for the first year and the second year is complicated. I tried to explain all this here. Now, what we found is that we had some losses, phosphorus losses, but not too high. And in the first year, there were not really many differences here, okay? Seems that the band and the broadcast only before corn or soybean were better in terms of reducing P loss that the broadcast either fall in the spring or surprisingly the broadcast with the rye. And for dissolved P, we see the same trend. Now, in the second year, there is some larger difference. There was more runoff, okay? And the big thing is that the spring, okay, broadcast or the spring banded were the lowest P loss treatments and were the same for the dissolved P. Now remember, this is all no-till. And as you can tell, I didn't put the proportion, but the vast majority of the P loss was dissolved P here, okay? So this study seems to support the theory that either banding okay, or the annual application broadcast, it could reduce some of the losses. So I think I need to cut this as usual. Otherwise, my boss here will start yelling at me very soon. But we also look at the impact of amendments such as alum, which is aluminum sulfate, and gypsum, okay? And I cannot show you the results, but what we show is that the aluminum sulfate really cuts a lot the dissolved P loss when it is mixed with poultry manure. It's really something, but the Iowa Egg Council funded this research years ago, several sites and years, but they never implemented this because they say that for egg layers, it's complicated to implement. Other research have shown that one is very also good with broilers, you know, when the chickens are not in cages. Now, we also work with gypsum, but applied with fertilizer, not in manure, and we found nothing. We used powdered gypsum, granulated gypsum, we found absolutely nothing. Here are the results. If you want to go back to the recording, you can look about that. And by the way, we have a project 4 years with Matt Helmers in Northeast Iowa and Ken Pesinowski, that we found that 1 ton application of gypsum to continuous corn with soy manure did not affect the nitrate or the phosphorus loss with tile drainage. Okay, the other thing that we are actually finishing up, and I talk too much so I cannot show details, is that we are looking at this issue of the total dissolved P, given that it's demonstrated that after filtering through a 0.45 nanometer filter, we can use directly ICP, and we measure total dissolved P by ICP, that we don't need the digestion. So that makes much cheaper the measure of total dissolved P. But we're finding that the DRP underestimates the total dissolved P, which is very active, you know, in receiving waters. So I'm just showing here an example or a study that we have tillage, no tillage, and we have fertilizer, soil manure, liquid soil manure, or no P. And this is the proportion, the y-axis, the proportion of dissolved P from the total P, okay? The proportion of dissolved P of the total P. And you can see the black bars is the total dissolved P. In all these cases, and there is an underestimation of DRP of the total P. We just finished a project, by the way, the news release came up yesterday, before yesterday, that we look at the impact of other management practices on this difference between the dissolved reactive P and the total P, but I did not have time to put it today. Okay, in summary, I think that it is clear that no-till increases the proportion of dissolved P in runoff, and we can also increase the loss, okay? Always increase the proportion of dissolved P, okay, in runoff. And sometimes often increase the actual loss too, even though the total P loss is reduced. The same happened, but not so clear with the buffer strips and with other practice. So I believe that these last 2 issues in these slides are important from the perspective of reducing dissolved P loss. Don't build up P. Don't apply high buildup rates, especially when these are applied to soybean residue, okay? And then all the soil conservation practices that can be used are much more effective in the soybean residue than in the corn residue. Okay, so those are things that we should have in mind. Okay, I'm hoping that some people want to stay a few minutes more, Matt, if there are questions. But if you need to cut, that's okay with me. Thank you.
We will see if there are some questions. Thank you very much, Antonio. We give you a virtual round of applause. Tremendous amount of work. And I would just highlight that I think some of the work that's been funded by INRC, there are detailed final reports on the INRC website. You do a great job of getting those final reports. I did have a question, but you highlighted it there at the bottom that my one takeaway is that we should be applying annual maintenance rates rather than a maintenance rate every 2 years.
Yes, or apply the double rate for soybean.
Before soybeans with corn residue.
Yes.
Yeah. Okay.
Now, this is something that farmers don't want to do it. Now, some no-tillers do. I work with some no-tillers that they do it because when they go, especially with the floaters, broadcast on corn residue and no-till, there is less compaction, you see, in the fall when they do that before soils freeze. So I think that this data, and I have more data that I didn't show, indicates that that can be done, and especially the 2-year rate before soybean. You see, if farmers or consultants, the objective is just maintaining. See, remember that most people in Iowa are maintaining high testing soils. So they're applying, in many soils, PIDA is not needed, okay? But if they apply, you know, before soybean, then there is absolutely no doubt. We have data with yield. We have 6 or 7 long-term trials that applying the P, the 2-year rate before corn or before soybean is exactly the same thing, and is also the same as applying the individual maintenance each year.
All right. Are there other questions that anybody might have? You can either type them in or feel free to unmute, I think.
Please, anybody feel free to contact me, you know, with questions. And I can supply this PowerPoint too, if the nutrient center allows me.
Yeah, we'll allow you, plus the presentation should be up here in a few days. So yeah. Any other questions?
Hey, Antonio, I'll ask a question. It's John Kovar.
Yes, how are you?
Good. Great presentation as usual. I was just thinking when you were showing some of the data here for your P losses. So in one of the slides earlier on, you showed that when you applied 100 pounds of P2O5 per acre without incorporation, you lost a total of about 1.5 pounds of P2O5 from that. So I'm thinking this has got to be kind of a hard sell to producers if you're out there, you know, talking various grower meetings, that if a guy says I'm applying 100 pounds and I'm losing about a pound or so, to me that's, you know, that's just within error of the fertilizer application equipment. So this has got to be a hard sell. You got to explain to him that even that pound of loss is important for water quality, because, you know, strictly from the expense of the fertilizer, that's not much loss at all. So that's just a comment more than a question.
Yes, no, I agree with you. Now, of course, these are averages, John, remember? I couldn't show individual years. So that's an average of many things, depending mainly on flow. But the key issue is that what we show with liquid manure or with fertilizer, that with those high rates, the proportion of dissolved P increases a lot. So this 1.4 that you mentioned is total P, but when we have these very high swine manure or fertilizer rates, maybe 70, 80, 90% of the P loss is dissolved P, you see. This is, I mean, this is very important, and in my opinion, I don't know if we will do, if the science team of the nutrient strategy will decide to consider dissolved P before I retire, but I think it's very important. You see, I think it's very important. Because right now in the P, 1 pound of P, doesn't matter the source. Now we do have the estimate for dissolved P there, but in the nutrient strategy, for all our practices, we have total P. So I think that, I don't think that we will be in the scarce situation that they have in Northern Ohio or in Ontario, because we have much less rain in the fall, much less snowfall here, in Iowa. But we need to pay attention to the dissolved P thing, especially in no-till.
And Antonio, maybe our last question, kind of getting at thinking about this TP and DRP, reactive P. Have you done work partitioning TP and DRP concentrations and loads among hydrologic pathways, including runoff, tile drainage, and groundwater?
Yes, with not groundwater, but with surface runoff, the information I have is in that final report, that I said it is posted. I think it was posted about a month ago. So there are details there, maybe more details that you need. So that shows the difference between the total dissolved P and DRP for different management practices. But the major impact, the major difference is the tiller system. And okay, what else? Yeah.
Looking at whether for different pathways, because I think what you presented mainly was runoff, but yeah.
Yeah, it's mainly with runoff. Now remember that we analyzed for 3 or 4 years the tile drainage from that national study, Matt.
Yeah.
And we see that the ICP, the total dissolved P is a bit higher than the dissolved reactive P, but not that much, we suspected, because there is not much soil in there. So I think that this should be put together in context with large watershed studies. Remember the objective of this talk was, and my work has been mostly within field stuff, but you are aware of some of the work, that mainly Bill Crampton is doing and others, that sometimes seems that we may be underestimating a bit the dissolved P loss from subsurface drainage or seepage, that is coming from some watersheds. So I think that the study of these things that I have with some of these other, say, watershed, large watershed studies, should give, better clues about what's going on about this issue.
All right, and I think next, that kind of a good segue for next month, Dr. Chad Penn will be here, or maybe even be here in person, but we'll be on to talk a little bit about tile drainage P loss, dissolved P loss that way, and practices we might be able to use to reduce that export to downstream water. So with that, kind of being conscious of folks' time. Thank you, Dr. Mallarino, for this information. Hopefully you're willing to welcome questions via email or phone call if they come up, and we'll get the recording up on the website soon. I thank everybody for tuning in today, and please tune in next month and maybe go back and watch some other seminars, seminars. So thanks, everybody.
Thank you so much.